Okay, today I will explain the functions we created for STM. Let's open project. I added some graphics here already, but it's just temporary, not permanently. Let's look at our decode function, which we're using for external VU4. I added read up, read down, step up, step down, and by pressing button switch modes. So here we can detect if it's read up, read down, or switching mode. Probably in future we will add volume regulator also. So as you see, I did some changes. I removed connection settings into separate window and added tuning knobs and meter. But we're talking about STM, so when it's connected you see green button. Now it's VF4, it's changing VF4. We press button, it's switching to read. We press button, it's switching to step. When we tune it, it's changing from 10 to 10,000. So let me show you the graphic. As I said, it's just temporary graphic. I just started to play with it to have our program looks much better. I created graphic external graphics ext CPP and graphics ext H file. In H file we write in our functions, which we can use from other applications, external functions. Internal functions we don't need to write because it's used only inside this file. So the first function is meter arrow. It's equation of ellipses. As you see, our meter is ellipsis arm, so we need to calculate the top point of the arrow to be always on the same place, always to be on the arm. So it's just math ellipsis equation to find x and y coordinates of the end of the arrow. Next is load pictures, load BMP file. Next one is draw bar. Next is draw text, draw line. Next is load BMP file from the files from the file system. Next is load here is this function is for meter is separate function. So we load in bitmap meter from the resource file. I will show you how to create it. Borland have option to create resource file. So we create we load meter file from the resources. Then we calculate the meter arrow position, draw the line by red color, and sending this picture to the form. So this graphics CPP file is written on the pure C++, so it can be used for any IDE, not only Borland. As I said before, I prefer Borland because it's easier for visual components. Visual C++ is a little bit harder. Need more knowledge about the Win API functions. So here when we build the form, we need to call this function show meter to show display, or to show the meter. This one is show meter. It have few variables inside. HDC, it's our canvas on the image. 0, 0, it's position of the image. Then 306 and 126 is the size of the image. So next one, we take out a picture of the knob from resources and show this image on the form. Knob have two images. One is the large circle, and second is the small circle inside. Also, we moved connection settings to the panel, separate panel, which we can hide and show. So combo boxes to select serial port, baud rate, we moved to this panel. And I added button refresh. If you connected radio later, then you run the program, then you need to refresh to see the serial port. And button settings is show and hide this window. When we build form, we want this window appear always in the center of the main form. So we need to create panel left and panel top. So we need to calculate position to of the left and top point of this panel. The left we calculate form width minus panel width and subtract it for 2. And panel top calculates same, but minus 25, because on the top of the form is aligned with buttons height, close. Also, we create a variable connect window. When we press the button connect, if connect window is true and panel shown, we hide in the panel and make connect window false. If connect window false, we show the panel. This red button we will remove later, because I already have an idea how to make it much better. So let me show how this knob is working. Now in this program only VFO knob is active. For read knob I didn't put the code yet. It will be in the next video. Next video we're going to work with the graphic. This one is, as I told before, program to create a resource file. It's called image editor. So we created graphics res. Here we have our pictures: knop, knop in, matter, read, read in, and read in one. Read in one and read in. I just wanted to play with the different pictures of the small circle. So we load knop picture to the image tree. Size is 177 to 177. So when we create form, what we are doing, HDC1 is image 8 canvas handle. Then we call function show image to take out image of the knob to this HDC. Next step, we need to load the small ring. So I created a variable. I created variable BMP. It's a graphics t-bitmap BMP, new graphic. So because it's better to work with image on the background, and when everything is finished, just only after that put it on the form. It will be faster. So we need to make it transparent, and transparent color is green. In RGB is 0, 2255, 0. It's our images. It's VFO knob. So all what is green should be hidden when we display it on the form. So we draw it on the image, not on the 0. We draw it on the 28. I just calculated how where it should be located. When axis y is 0, axis x is 28. I mean axis y0 for the center of the picture. But we are working always with the top left corner. Coordinates should be for that. For it also the same. We load read from resources. And then we draw the small picture. So now let's make it work. In image 8 we have 3 events: mouse down, mouse up, and mouse move. So on mouse move, it's here we are rotating our image. To make permission for that, we created a variable, logic variable, knob tune, and a second one for the read tune. Now it's false. When we press the left mouse button, if button equal MB left, we making knob tune true. First sample true. First sample is for calculating for the sending frequency. Now we don't need it. And then we need to check if our read info thread is active, because if it's not active, then we don't need to send any data into the radio. Because in other case we will get error. And on mouse up we making knob tune files, and if serial port is not available, we're not doing anything. So this one is our main function. There is integer cx, cy is center of the window, center of the picture, because picture is 177 to 177 pixels. Then we need to calculate position, position is x, and y, it's our mouse coordinates. So we need to calculate the distance from the center to our mouse position. For that we create double dx and double dy. Dx is x minus cx, dy is y minus cy. And then we need to calculate the angle between x-axis and the line which will be from the center of the picture to the point with dx and dy coordinates. So when we calculated angle, now we can find the coordinates of the picture when we're rotating. Integer x is equal cx, center of the picture, plus 37. 37 is the radius of rotation. And multiplied to cosinus angle, and integer x is integer y is cx plus radius multiplied to sinus angle. So now we are able. Now we need to redraw our picture. We call HDC, show image. We take again knob image from the resources. Then we load small knob from resources, making it transparent again. I think we may not do it here, because we already did it. BMP1 is a global variable. Just I did it to be sure it's always same. And then we draw small picture on coordinates x minus 32, y minus 22. It's because we calculated coordinates of the center of the knob in picture, but we need coordinates of the top left corner. If serial port is not available, we not do anything. If serial port is available, we need to calculate the angle between previous position, mouse position, and current mouse position to recognize the direction, tuning direction. When we calculate it, we need to compare if delta the difference we call delta, create variable delta, in which angle minus previous angle. If delta is more than 0, direction is will be right. So we making logic variable direction true. If less than 0, we making it false. And then we start the thread for changing frequency. I was trying to put right VFO function here, but in this case everything working very slow, so better to better to send command into the radio in background mode in separate thread. So let me show you this thread, and after we finished we need to make previous angle to current angle equal to current angle. So I created handle tune, and I created a thread Dword Win API tune by small letters. It have infinity cycle 1. When we started, we making refresh variable files to stop our timer to display any data, sending write VFO, then refresh is true, so timer can display the current frequency. Then we suspend this this thread. In form create we create this thread, but we created suspended. It's already created but not active. And when we move tuning knob, we resume this thread. It making one step, one time running write VFO frequency and suspending until the next step. So now when radio not connected, we just can turn it. As I said, read doesn't work yet. I didn't put any code inside this wheel. Okay, let's connect radio. Tuning knob is available. Okay, now you can see it's changing. It's much better to use this one instead of the buttons, because if you have a touch screen, it will be much easier to change frequency. In S-meter, I already added to CPP file with ICOM functions. I already add S-meter, SWR, power, ALC, compressor, all the functions. Just we need to add in future, we need to add switch between it. We will do it when we add transmit button, because SWR and power can be displayed only when transmitting. So, as I said before, in each file we only show the available functions for global use. So here we can see signal read, it's S-meter, SW read, ALC read, compressor read, voltage and current. 6 functions. I also tried to play with the graphics to make a volume regulator, because in our main thread read info we already have these functions. So when radio is connected, program is automatically reading this data every cycle. So I created a bar and small rectangle, but to be truth, I don't like how it's working. I'm going to draw different one, which will be looks better with gradient color. You see, it's very small and very hard to catch it. So I did it just for displaying and writing these functions. Finally I got it, but it's moving a little bit slow, because write audio frequency and write radio frequency functions are inside the on mouse move. We need to create separate threads to send and receive commands from radio in the background mode. But now for beginning it's enough. Let's save everything. Next video I will try to add more graphics. Before we start with the sound, I will add more graphics to make better displaying of the frequency. I don't want to use label because we're not able to send data to label from the Win API threads. We need something else. I will do something with graphics, and I will take digits from the ICOM 730. It have a very nice large digits, and it will looks much better.